happening to it. It's kind of wobbling about a little bit. But what you should see, aside from the very large fluctuations, is that it has that kind of grainy texture that's characteristic. If you've seen lasers before, then you'll know that grainy texture. So let's think about why that happens, and you can demonstrate the strangeness of that graininess if we do a little test. What I'd like you to do is, not diffraction vectors this time, just close one eye, hold up one finger, so that the fingers kind of, the spot is just behind your finger. Now, normally, if you now focus, hold your finger about 20 centimeters in front, if you focus on your finger, then the writing should go out of focus. That's what normally happens. If you focus on the writing, the finger goes out of focus. Yeah, that works. So now what I want you to do is look at the grainy texture on the green spot, and then focus on your finger rather than the back. What happens to the grainy texture on the spot? Does it go out of focus? It shouldn't. And the interesting thing about that is it doesn't go out of focus because it's not there. At that point in doing this with students, I just move on and see how many of them notice that, see how many of them notice that. Actually, it isn't that pattern. If you put a camera there, you would not see that pattern. What's going on is that light from different parts of this bead are coming out into the audience, and they're combining in your eye. And if the distance is such that the crest of one wave overlaps with the trough of another, you get a black grain speckle. And if the crest overlaps one wave overlaps with the crest, then you get a bright green grain. So the pattern is actually being formed into space, inside your eye. It does some other interesting things. If you look at it again with one eye and move your head from side to side, slowly, which way does the pattern move compared to your head?
Opposite.
Anyone see it go the opposite way?
Yeah.
Same way? That's because it's the afternoon, strangely enough. What's going on here is if you're short-sighted, you'll see it move opposite. If you're long-sighted, you'll see it move the same way. If you've got glasses on as well, if you look over your glasses, and what you should see is that it moves much more quickly. Can you see that? So that's the strange business of it being not there, but in space. Normally, what happens is that when you see something, it's focused on your retina. If you're short-sighted, then the light is focused in front of your retina, so your retina's there, and the light's focused there. That means when you move your head, the two move relative to each other. And if you're long-sighted, the retina's there, but the light's focused back there, so it actually moves the same way. So the pattern in space is actually moving relative to your eye. That's what happens. If anybody thinks they have perfect eyesight, and that's moving a lot when you move your head, then I'd advise not driving back to the room. It's actually quite a sensible test. Also, in the afternoons, people tend to get dehydrated and their eye changes shape, and that means that people don't tend to have perfect sight in the afternoon. Anyway, so a couple of examples of lasers. We could spend the whole afternoon talking about lasers. I'll give you a couple of examples.